All right, so again, this is very similar to what we did yesterday, with the exception of yesterday, it wasn't in equation form. We had to put it equal to x, and then we would solve from there. So today, it's already in equation form, and again, our variable is going to move from the base to the argument to the exponent, and depending on where that variable is, will determine how we're going to solve each equation. Either way, though, you're going to go straight from this log equation, and you're going to move it into exponential form. Okay, so for the first one, we've got log base 2 of x equals 4. So to be able to solve this, the very first thing I want to do is I want to take it to exponential form. If I can move it. Okay, so we start with our base. It's going to go 2 to the 4th power equals x. And sometimes it's pretty straightforward to solve. When our x is the argument, then all we have to do is figure out what that value is. This says that x is equal to 2 to the 4th power. So we just have to figure out what that is. I don't have to solve for x because it already tells me what x is equal to. I just have to simplify that value. So what is 2 to the 4th power? 16. So guess what x equals? 16. The only thing that we have to be careful of is with the arguments. Everybody understands which part of the log is the argument, right? Not the base, but the number it's next to. That can never be a negative number. Okay, so when we're simplifying, you should never get a negative argument. All right, go ahead and try 2. It is in equation form, so we want to get it out of the log equation by taking it to exponential. We are once again solving for our argument. We do not want anytime a number has an exponent involved, you want to actually simplify that out. Tell me what that is equal to. Again, we'll go to exponential. 4 to the negative 2 power equals x. We do not want to leave any negative exponents, though. What does that negative 2 tell me to do with that 4? Move it to the bottom, right? So that's going to become 1 over 4 squared, which is just 1 over what? 16. Go ahead and try 3 and 4. Variable moves in 5, but go ahead and try 3 and 4. For number 3, 12 to the 0 power equals x. What is anything to the 0 power? 1. Okay. And then second, or number 4, 1/2 to the third equals x. Remember, when you raise a fraction to an exponent, that exponent is going to go to both the numerator and to the denominator. So if I did 1/2 to the third power, that's going to be 1 to the third power and 2 to the third power, which is going to give me 1/8. Everybody okay with those? A variable in the argument, take it to exponential, and just simplify the value. Whatever the number is, raise the exponent, simplify it, and write it how it needs to be written. Don't leave any negative exponents. And we don't want to leave any decimals either. Now, do you notice in 5 and 6 my variable moves? It's not my argument anymore. So these are going to be very similar to what we did yesterday. But again, the very first step we want to do is to take it to exponential. So take that log, put it in exponential form, and we're going to talk about what to do in this case. Just like yesterday, taking it to exponential. I'm going to go 4 to the y power equals 64. At this time, the variable's in the exponent, so we're going to have to do like we did yesterday, and we want to write both sides of the equation with the same base. Okay, you got your little chart there. It's 4 to some unknown power equals 64. And yes, I know some of us already know the answer. However, looking at your chart, is 64 a power of 4? Look at your list. Find 4 for your roots. Scroll over. Do you see 64 anywhere? Yeah, it's going to be 4 to the what power? Third. So what we're going to do is we're going to keep this 4 to the y over here. And I'm going to change that 64 into 4 to the third. It still equals 64. I just wrote it in a different form. Once you have both sides written with the same base, then you drop the base, or drop the bases, set the exponents equal, and then solve. Sometimes you have to solve, sometimes you don't have to solve, sometimes it's already solved for you. So I now have the same bases, so I can drop the bases and set my exponents equal. And what is this y going to equal? 3. Now I want you to try 6, but you're going to have to remember what we did with the fractions yesterday. Take it to exponential. We need to write both sides with the same base, so I'll give you a hint. That base is going to be 2. We did one very similar to this in class yesterday. Taking it to exponential. 1/2 to the y power equals 16. How did I rewrite 1/2 as the power of 2 yesterday? 2 to the -1, yep. And then 16 is 2 to what power? 4th. Okay. Now keep in mind, we multiply those two little exponents, so that becomes 2 to the -y equals 2 to the 4th. I have both sides with the same base, so now I can drop the bases and set my exponents equal and solve for the variable. So I get -y equals 4, which means I then have to divide by -1, and so y is going to equal -4. Do I have any questions? No? All right, take a minute and write number 7 down. Yeah. First step is the same every time, no matter where your variable is. In this case, my variable is in the base. So we're still going to take it straight to exponential. Real quick though, when we talked about logs the first day, we said the base was not allowed to be negative, and it's also not allowed to be 1. Okay, it can be a fraction. It just can't be negative and it can't be 1. So if your variable is in the base, be very careful about what kind of answers you're leaving. You cannot have a base of 1 and you cannot have a negative base. So we're going to take that to exponential. So in order to be able to solve for my variable now, I have to get rid of my exponent. Okay. Sometimes it's very easy like this one, and we know that if it's a square, we just do what to undo a square? Take the square root. But if my number happens to be some different, like a fraction, for example, do you guys remember how we solved it? Not necessarily taking the square root of it, but we raised it to the, what's it called when you flip a number upside down? Reciprocal, right? Raise it to the reciprocal power. So what we're going to do is we're going to raise both sides. To the reciprocal power, and I mean the reciprocal of the exponent. What's the reciprocal of 2? 1/2, right? We've done these before. We did them back with our exponents. And remember, when we raise it to the reciprocal power, when I multiply 2 times 1/2, that just turns to what? Just 1, right? So it's b to the first. And then how do we simplify that? 49 to the 1/2 power, we take the what root? Square root. Yep. And raise it to the, my pen will work. First power? For which one? Oh, for the fractional thing. The bottom number is the root we take. The top number is the power that we raise it to. Okay. What is the square root of 49? And 7 to the first power is just 7. Now, I know a lot of you could have just looked at that b squared equals 49 and told me that it was 7? Yes. Okay. Here's the thing, though. Let me ask you this. If I were to solve it by just taking the square root, which is okay as well, taking the square root, what do we usually put in front when we take the square root? We usually put a plus or minus, right? But what did we say the base could not be? Negative. Okay, so we would never want to do that. Even if I did just take the square root, you do not need to put plus or minus because we cannot have a negative base, so you would just use the positive value there. Does that make sense? A little bit. All right, I want you to try 8. Take it to exponential, raise both sides to the reciprocal power, and then you're just going to simplify the remaining value. Take it to exponential. What would this be exponentially? B to the 4th equals 81. Again, is it okay if I just undo the 4th power by taking the 4th root? Yes, that is the same thing as the reciprocal. We just need to understand that if that exponent on that base was something other than a whole number, we would need to then raise it to the reciprocal power. So I'm going to continue with that just to stay consistent. What is the reciprocal of 4? 1/4. Okay. So that means we're going to take the 4th root of 81 and we're going to raise it to the 1st power. You have your little chart there. You can look for 81 under the 4th columns. Go back to the root. What is the 4th root of 81? 3. And 3 to the 1st power is 3. That making a little bit of sense? Let's see. What else I got there? Hold on. Okay, yeah. I want you to try 9 and 10. Sorry, I was just seeing what else I had. Try both of those. Don't let that square root mess you up either. 9, my variable, is the base, so we're going to have to follow those directions. 10, my variable, is the argument, so we're going back to some of the original questions we did. No matter where the variable is, the first thing we do is go to exponential. Now my exponent is negative this time, isn't it? So I can't take a negative. Can you take a negative square root or something? No. Okay, so let's use the reciprocal. What is the reciprocal of negative 2? Negative 1/2. Okay. So that means we are going to take the square root, and then we are going to raise that to the negative 1 power. What's the square root of 64? 8. And 8 to the negative 1 power would be 1/8. Not a negative number, not 1, so that is a good answer for that base. Anybody have any questions there? All right, number 10, let's take it to exponential. My variable has moved now back to the argument. So it is going to be the square root of 2 raised to the 4th power equals x. A couple of different ways you can do this. Square root of 2 to the 4th power means I'm multiplying it how many times? 4. So square root of 2 times the square root of 2 times the square root of 2 times the square root of 2. Can I multiply all of those together? Yeah. What's 2 times 2? Times 2 more? 8 times 2 more? So that simplifies to be the square root of 16. Can I simplify the square root of 16? What is that going to be? So x is going to equal 4. Anybody have any questions so far? All right, let me see. Go ahead and try 11. You can hold off on 12, although 12 is not really difficult, but I want to do that one with you. I want you to try 11, though. The variable is in the base again, so follow those directions. Remember, with a log, your little number is the base. The big number is the argument. And what it is equal to is the exponent. So that you know what I'm talking about when I say base, argument, and exponent. Number 11 might seem difficult looking at it, but once you set it up, hopefully it won't be so difficult. What's this thing look like exponentially? B to the equals 4, 3 to 5. So far, so good? All right, reciprocal power. What is the reciprocal of 1/4? 4 over 1, or just 4. Okay, so I'm going to raise that. Finish my thought up here. So these two cancel out and go to 1, so that's just b to the first. But if I take a fourth root and raise it to the fourth power, don't those two things just basically cancel each other out? So what's left? 5. It seems difficult. But you just have to understand that 1/4 and the fourth root are the same thing, so they're going to cancel each other out. Everybody ready for 12? Sure, can't wait, yay. Okay. All right, we're going to take it to exponential, starting with your base. It is 2. Get a different color. 2 to the third power, and that's going to equal everything inside the parentheses, okay? That whole stuff inside the parentheses is your argument, okay? They just keep it in parentheses so that you know that that all belongs together as the entire argument. Okay, the variables in the argument. Take it to exponential, and then we're just going to simplify. In this case, we actually have to solve a little bit too because I have an equation. What is 2 to the third power? 8. And now it's just a regular basic equation to solve, right? What would I do first? Add the 2, yep. 8 plus 2 is 10. Then we're just going to divide both sides by 2. And so what is x going to equal here? 5. Okay. We just have to make sure, because the variable is part of the argument, if I plug a 5 in there, does that argument stay positive? 2 times 5 minus 2, is that positive? It is. Okay, so that is a good answer, and I don't have to worry about tossing any answers aside. Everybody okay? I think I got like 1 or 2 more maybe. Let me see. Oh, no, we're not going to do that one. I'm not going to do that one either. I'm going to keep it simple. We'll call that quits. Go back to 10.